right, here we go. So Megan, this was problem which one? Problem 148. This is a trig subsection, and it was the square root of 1 plus x squared over x. Okay, now, of all the ones that I've seen, I believe this problem ends up being the most difficult. Okay, that's my thought. Now, there may be one out there that is tougher, but not that I've seen yet, or that I've worked out. So, what's the substitution here? It's a tangent, right? So x equals tangent theta. Dx is secant squared theta, right? So now we have square root of 1 plus tangent squared theta, secant squared theta, d theta, over tangent theta. Yeah? So everybody good there so far?
Wait, why is it all over tangent and not just the first part? Oh, never mind.
Y'all, you mean why is that fraction bar so big? Because it doesn't matter.
Yeah.
I mean, still the same thing, right? Okay, so 1 plus tangent squared, secant squared, right? And the square root of secant squared, secant. So this ends up being secant theta times secant squared theta over tangent theta. Yes? And then it's secant cubed theta over tangent theta is probably what a lot of us would have done. But it turns out that may not be helpful. Okay, so when I got here, when I got to this spot in this problem, I wasn't sure what to do next. I had to go through some thinking. It just wasn't obvious to me right away. Okay? The first thing I did immediately was I tried to simplify this. Okay? So off to the side, I said, okay, secant cubed is the same as 1 over cosine cubed, divided by tangent is the same thing as multiplying by the reciprocal of tangent, which is cosine over sine. And then I said, oh, okay, so cosine, so that's going to be 1 over cosine squared times 1 over sine. But sadly, that doesn't help me. Because if this were cosine squared times sine, I could do it just fine. But it's 1 over cosine squared and 1 over sine. And 1 over cosine squared, yes, is secant squared, times 1 over sine is cosecant. If you note, like, those two guys don't go together. Like, these guys have never hooked up in a problem before. So I kind of abandoned this. I said, okay, simplifying this may not have been the best route. So then I went back and I said, okay, well, let's do this. I'm going to go back to where I was right here, and I'm going to rewrite that. Instead of calling that secant of theta times secant squared, I'm going to call that secant of theta times 1 plus tangent squared. Okay? And then I'm gonna every time I take the lid off of this, the whole thing comes apart. Then I'm gonna distribute this. Like that. And And now this is a common thing that we do. When you have two things in the numerator and one thing in the denominator, it's often very useful to break that up into two separate fractions. So now I'm going to write this like this. Okay, so what's secant divided by tangent? Does that simplify? Secant divided by tangent simplify. It ends up being 1 over sine, right? Which is AKA cosecant. And does this simplify? Oh, yeah. So now we're there. So do we know the antiderivative of cosecant? You probably have not memorized that. And I don't know that I would have expected you to. We did do it in class when we learned the antiderivative of secant. It's almost identical. Demi's looking it up. What is it?
It's negative natural log of cosecant plus cotangent.
Exactly. Whoa. And what's the antiderivative of secant theta tangent theta? What function has a derivative that's equal to the secant theta tangent theta? Secant. What are you laughing about? Are we done? No, now we got to go back and put it in. Oh, for goodness sake. Okay, so x equals tangent theta, right? So that means x over 1 equals tangent theta. So here's theta. Hello, theta. X over 1, square root of 1 plus x squared. Okay, so negative natural log of cosecant. What's the cosecant? Reciprocal of sine is what you meant, but so it's sine is opposite over hypotenuse, so this is Haas, right? Or Ho, right? So the cosecant is going to be radical 1 plus x squared over x. Cotangent is reciprocal of tangent. And then the secant is reciprocal of cosine, which is that over 1. If you want to stick it over 1, you're certainly welcome to. And there we go. Megan, we didn't finish this out, did we? We didn't draw the triangle. I was going to say, because that answer is not, just isn't ringing a bell. Yeah. I think we just stopped here, right? So that one was kind of challenging. I mean, you know, and interestingly enough, the substitution was actually really easy. You didn't have like x equals 3 tangent theta, or you didn't have any goofy fractions involved. I mean, the substitution is pretty easy. But when you got to here, it got difficult. Did anybody do this a different way that I didn't see? I mean, it's certainly possible somebody might have done this a different way and I didn't see it. Okay. Do you have to know the antiderivative of cosecant? No, probably not. If you know secant, you're going to probably be okay. If you ended up needing it, like say on a test, and I end up lying to you by accident, then I'll just give it. But they are pretty similar. You know secant. It's like, if you know secant, you pretty much almost know it.
What's secant again?
Secant is the natural log of secant plus tangent. So, I mean, cosecant is the exact same except the cos, and it's negative, but that always happens. So, okay. How do we like that? Love it? You think, man, trig subs are the greatest thing ever. I told you, I thought trig subs, when I learned this in high school, I thought trig subs was like the hardest thing I've ever seen. And then what I thought it was hard because it just took up a lot of room on the paper. Like that's why I thought it was hard. Like all these steps, like this is just so hard. But if you stay in the problem and you don't bail, it's not near as bad as you might think, but they are difficult. I don't want to. All right, what else do we have? Any other questions you want me to do, or? Let's erase this baby. Nada? So we're good? We could have just taken that quiz today on trig subs, and you're all happy and. I mean, no questions to me means one of two things. Either you didn't do it or you did it right. Right?
What about 153?
What is that one?
It has bounds.
It has bounds?
Yeah.
Oh my gosh! We haven't done one with bounds. What is it?
Okay, so the integral from -1 to 1 of 1 minus x squared to the 3/2 power.
Just like this?
Yep.
Oh. Okay. Boy, that would be so much nicer if there were an x right there, wouldn't it? Because then it would just be a u sub. So Becca's, what did you make a substitution?
Made x equals secant theta.
You made x equals secant?
Yeah. Is that wrong? That's what I did.
Why did you do that?
I don't know. Because I thought I should.
So this is in the form of like a squared minus x squared.
So like sine.
So it should be sine.
Well, it was the last one of the homework.
Oh, so you were just kind of exhausted. So let's do x equals sine theta. What's dx? Cosine theta d theta. All right, so here we go. Ready? So this is 1 minus sine squared theta to the 3/2 times cosine theta d theta. Right? Yeah. What are you thinking? Or are you thinking? Just waiting for me to think for you. Okay, so if I follow what I kind of always have done with trig subs, the next step here would be to change that 1 minus sine squared into cosine squared. Right? but do you see the issue with that? Let's just work it out and let's let the issue develop if you don't see it. So I'm going to call that cosine squared, right? And this is raised to the 3/2. And then that's times cosine theta. Yep. So right now, friends, we don't have, like, I need a sine. I need a sine. I mean, I need a sine theta, right? Like, in order to do this the way we've been doing them, we need a sine theta. Okay? Now, if I continue on, what's cosine squared raised to the 3/2? Like, what do you do when that happens? You multiply the exponents, right? So that's cosine cubed times cosine. So it ends up being cosine to the 4th. Right? Everybody agree with that? Now, we have one of two options here at this point. We could continue on and try to find the antiderivative of cosine to the 4th. Or we could have gone right back here to this. Okay? But I think since we didn't do that, here, let's just keep going with this, cosine to the 4th. Okay? So, how we do cosine to the 4th? I feel like maybe you've already had that problem before, but maybe not. Did you have cosine to the 4th at some point? Did you have sine to the 4th at some point? So cosine to the 4th, well, isn't that the same thing as cosine squared squared? Right? And isn't that the same thing as, cosine? Sorry, let's do it this way. I just changed my mind. Cosine squared squared. Yeah? And isn't cosine squared the same thing as 1 minus sine squared? Uh-oh, we're still gonna run into a problem there. How are we gonna do cosine to the 4th? How are we gonna do that? So does anybody see why I'm stopping? Why am I stopping? Like, what's causing the angst right now? I don't have this all in terms of one thing with an extra cosine hanging on me. Or I don't have this all in terms of cosine with an extra sine hanging on me. Right? Now, I could do this, I suppose. I could FOIL this out. What would happen if I FOILed this out? If I expanded that? Well, it's 1 minus sine squared is 1 minus 2 sine squared theta, right? Plus sine to the 4th theta. Agreed? Does that help me?
No, there's still no cosine on that.
Still no cosine on it. What are you thinking?
Is this like the double angle rule with the 2 sine? Well, squared, which I haven't seen.
2 sine squared? Is that one of the double angles? No, but I do know the antiderivative of sine squared. I do know that one. Do I know the antiderivative of sine to the fourth? What are you thinking?
Can we go back up to the step before we turn 1 minus sine squared into cosine squared, and then make u equal sine, and then the du would be cosine, and then u sub.
Okay, so what happens if you do that?
I don't know.
So we want to hit a pause here. So like this is the pause button. So Becca wants to go back here. Right? And she's saying, what if I said, do that as a u sub? You're going to end up getting what? U equals sine theta. Du is cosine theta, right? So what are you left with? 1 minus u squared to the 3 halves du. Right? But look very carefully at this, friends. And then look very carefully at this. It's like the same problem, right? Yep.
If you go back, can you just do like 1 to the 3 halves minus sine squared to the 3 halves? Because 1 to the 3 halves is 1, right?
Oh, okay, hold on. So you're back over here. So we're cool with abandoning this. Like we see that this didn't get us anywhere. It just got us right back to the original problem with different numbers or different letters. So now you're saying when I'm right here, I can take 1 to the 3 halves and sine squared to the 3 halves. So you're telling me that we don't FOIL anymore and use the distributive property anymore? Yeah. So that's no good. Dang. How are we going to integrate cosine to the 4th?
Okay, I don't know if like you're able to do this, but like where it's like the integral of like cosine squared and math squared, can you just, since we know the antiderivative of cosine squared already,
Can I
we
just
write
square that?
Yeah.
It'd be really nice if you could do that. Well, here's a simpler example. If that worked, if that was a rule, it would be a rule all the time. So you're telling me that, so according to Annie's rule there, I know the antiderivative of x squared, it's x cubed over 3, right? So I can just square that, and I'll get x to the 6 over 9. That's not the same thing as the antiderivative of x to the 4. So we're stuck at cosine to the 4th. We got to do cosine to the 4th. How are we going to do cosine to the 4th? Desmos. What's Desmos? What's photomath? What does photomath tell you? Can photomath do this? Can you just type a problem into photomath, or do you have to actually take a picture of it? How do we do cosine to the 4th? I actually can't remember. I'm thinking this out loud right as we speak. I don't remember. I have some ideas. So I'm going to unpause that, I guess. How are we going to do cosine to the 4th? It's been a long time since I've done this. I almost don't want you to tell me that. Because I want to figure it out. So what are our options right now with cosine to the fourth? We can try to continue on where we are here. Okay, well, I mean, what we've done here so far, I mean, none of this isn't wrong, right? That's not wrong. That's not wrong. But is that helpful to us? Right now, I'm leaning toward no. I mean, I've sine to the fourth now. Well, how's that helpful? I don't know what that is. Okay, if it just was those other two terms, I'd be fine, right? So maybe I'm going to go back here to cosine to the fourth. Maybe try it by parts. Ugh. How would we do that by parts? So I'm going to redraw my pause button and start here with cosine to the fourth. How would we do that? Are we going to run out of time? Yeah. Oh, maybe. So how am I going to set the parts up? I mean, you have. I mean, you could do cosine squared and cosine squared. Is that legal? Sure, it's legal. The question is it useful? Right? What's du then? This is 2 cosine theta times negative sine theta. And what's v? What's the antiderivative of cosine squared? So what happens when I do this? U times v, so that's cosine squared theta over 2 times theta plus sine theta cosine theta, minus the integral of v du. So I can see that the 2's are going to cancel, right? Everybody agree with that? So then I'm going to have cosine theta sine theta times theta plus sine theta cosine theta. And then this is, because that negative right there, I'll turn that into a positive. So what do we think? That second integral there. What do you think about that? What do you think about that second integral? This guy right here. If you have to distribute this, you're going to have theta times that. And I don't know what that is. And then I'm going to have cosine squared sine squared, which is kind of messy too. Dang it. Ethan, I really like what you were saying earlier, but I'm not sure if you realized what you were saying earlier. So call it. Where's Ethan? You're Ethan. Yeah.
If you do cosine squared times 1 minus sine squared, when it's cosine to the fourth, and then you distribute it.
So, right. So you want to say this right here is 1 minus sine squared times cosine squared? Okay. So then you're saying that's equal to cosine squared times, or minus cosine squared theta sine squared theta? Well, I know this. but I got a sine squared. If this weren't sine squared, that would we would be golden, right? I think I figured it out while we've been standing here. I'm like 80% sure I figured it out. I didn't when we started. I mean, I'll be honest, I didn't. Like, and it's good for you to see me go through like what you have to go through. Like, it's good for that. I mean, so you can see how I process things when I don't know how to do something. Like, that's a learning experience for you because you should try to do the same thing. Like, you know, it's so much easier for me when I just know how to do it. And it's, you know, oh, you can just watch. Oh, yeah. But, you know, it's like with Megan, you and I were talking about earlier today. It's what do you do when you don't know the answer is really the significant thing here. Like, it's all fun and games when I know that, yeah. But when I don't know, like, what do we do? Like, well, I got to go through some thinking here. I think we're going to end up using that identity that you wanted to use earlier. Because cosine squared, okay? Remember, cosine of 2 theta was 2 cosine squared theta minus 1, right? Is that true? So cosine, if I solve this for cosine squared, I'm going to get cosine of 2 theta plus 1 equals 2 cosine squared theta. So cosine squared is cosine of 2 theta plus 1 over 2. Okay? This is helpful to us. Why? And maybe it's not that. What's the sine squared equivalent to this? Isn't it 1 minus cosine of 2 theta over 2? Isn't that the sine squared equivalent of this? Because remember, cosine of 2 theta is also equal to 1 minus 2 sine squared. So solve that for sine squared. You guys are confused. You don't know what I'm talking about. Like, I'm looking at your faces like, he's talking in a foreign language right now. What I want to do, okay, and I'll work this out for you and I'll put it in the video. The problem with this right here was when I expanded it, I ended up with a sine to the 4th, right? Sine to the 4th is not helpful. Sine squared is doable, right? So what I'm going to do is I'm going to reduce this cosine squared into a sine to the 1st, but it'll be of 2 theta, not of 1 theta. This problem obviously would not be on your quiz. You will have much simpler one on your quiz. I'm going to work out right now. Ooh, yeah.
We didn't even get to the bounds.
The bounds are easy.
No. Once you figure it out.
Oh my gosh, it's so easy.
Just remember, I won't be in class tomorrow.
Okay, neither will I.
Oh, yeah, right.
Figuring it out. Oh, I never sprayed. When are you leaving, Gavin? Don't you have dive today?
Yeah. It's like,
Oh, is it tonight? Oh, we got Carrie spraying. Carrie's on the spray.
I thought you said it was good. Yes.
are you gonna have a test this quarter?
We're gonna have a test this quarter.
Are we going to?
Yeah. Probably 2.
What week are we on? 4, 5?
I don't know. I'm not sure. If this week weren't so jacked up, we probably would have had a test this week. But well, that's probably not 100% true. But we're behind where we should be. These Wednesdays are killing us. In fact, we're probably gonna have to change Wednesdays. Like Wednesday's no longer gonna be the day to do nothing.
Yeah, I wonder if like we're not gonna be here for the rest of the year.
I hope not. But I got stumped last period. Or the interval, I couldn't. Just didn't know how to do it.
You couldn't do it off the top of his head.
Ooh.
That's probably recorded. Because it wasn't.
Coach Baker.
Yeah, we're back.
Oh boy. I didn't tell him last night. He said it was originally supposed to be a day since we had a Tuesday off. Like the substituting the sign and retention. Made up. Well, today was supposed to be.
Hello, Nicole. Hello, Carrie.
I think we were supposed to work stuff yesterday.
What?
I got stumped last period.
By what?
A problem.
I haven't.
I mean, I figured it out. But it was I didn't know how to do it right away. And it's good though. They don't see it as good. But how do I integrate cosine to the fourth? Did you do it?
I don't remember. Let's find out. I feel like we did that.
If you did that and did it correctly,
I did do it.
you did it correctly?
I don't
Did
know.
you do it or did Photomath do it?
I did it. I don't know if I did it correctly. I don't think I did it correctly.
Photomath. I'm not sure about that Photomath.
But I didn't think it. Because I put X in for sine theta. Right?
What?
I'm just talking about it. I'm not really talking about it. I'm trying to figure out if I did it right or
Did
not.
it go, man? Is it time to start?
No.
I don't know.
Vernon going down to Miami with you tonight? How are you getting there?
My mom's driving.
Your mom's driving. Yeah. Good. Yeah.
Is the integral of cosine to the fourth 1/4 cosine cubed theta times theta plus 3/8 times theta plus times?
Same, I have no idea. I mean, I know how to do it. I haven't worked it out though. Like, I don't know the answer.
I didn't know what you said. Like, did you do it correctly? So I didn't even.
No, I haven't done it. But I got to this point in my period, I was like, shoot.
I put some down on paper.
Okay. Where's the bell? Get it?
I don't think we have
Don't
one.
they not ring during?
Oh, that's right. We don't have a bell now. It's lunchtime. Oh, yeah, we don't. So, okay, here's the plan. I originally was going to give you a quiz today over trig subs, but I just decided that would not be. That wouldn't be right. Because you just need to have an opportunity to ask questions. So, what we're going to do today is we'll talk about some trig sub stuff. If there's time, we'll pick up where we left off in the video that I posted yesterday about partial fractions. If not, then what I'm going to do is this afternoon I'm going to make a video that is going to be the continuation of that partial fraction thing that you will then watch in class tomorrow after you take a quiz on trig subs. And then you'll have problems to work on over the weekend with partial fractions. So I'm not going to be here tomorrow, so that actually, it'll be good that you can watch a video. You know, you'll have something. You won't just lose the class period. So yeah. That sound good? Okay. Well, there's one problem I want to work out for sure, and now there's another one, I guess. The one that I wanted to work out for sure with the trig subs, which I thought was the hardest one. Now it turns out maybe the hardest one is the one that I end up getting cosine to the fourth, but now that I know how to do it, it's not so hard. It's just 15 minutes to get there. But the one that I was really interested in working out for sure was this one right here. I think it was the square root of 1 plus x squared over x. Which problem was that? You may remember? 148? Okay. So if I'm looking at that problem, what's the substitution that we made for that problem? It's a tangent, right? So I'm going to say x equals tangent theta. So dx is secant squared, right? So now I have the square root of 1 plus tangent squared times secant squared over tangent theta. Everybody good on that? So what does this end up being here now? Well, 1 plus tangent squared is secant squared. Square root of that is secant times secant squared is secant cubed over tangent. So now we're there. Now my first instinct when I saw this, secant cubed over tangent, was to try to simplify that. Now, does everybody understand why we can't proceed with just a straight u sub with secant or tangent, the way we've done? When we've had problems with secant and tangent hooking up before, you could do a u sub. But does everybody see why we can't do that here? Why? What? You said it. tangent is on the bottom. Like that's what causes a wrench in this. Now, if tangent were in the bottom and that was secant squared and not secant cubed, fine. Okay? But that secant cubed is really making it painful. So my first thought would be to simplify it. Can you simplify secant cubed divided by tangent? Can you simplify that? And the answer is yes, so everybody do it. Can you simplify secant cubed over tangent? Secant cubed is 1 over cosine cubed. Dividing by tangent is the same as multiplying by the reciprocal of tangent, which is cosine over sine. So 1 over cosine cubed times cosine over sine. Doing this off to the side, boom, boom. That's 1 over cosine squared times 1 over sine. 1 over cosine squared is secant squared. 1 over sine is cosecant. So I have secant squared times cosecant. That's what that becomes. Is that helpful? Why is that not helpful? Well, we've never had these two hooking up before. Normally, secant's hooking up with tangent, right? Not cosecant. So now what do we do? This is where we're at a little bit of a crossroads. This is where we have to start getting clever. Well, what we've done in the past when we've had a secant cubed is maybe written it like this. Which is what I have, kind of right there. And then that secant squared is the same thing as 1 plus tangent squared. Which makes it equal to up here, I'll go up top. That's secant theta plus secant theta tangent squared theta over tangent theta. Okay? Is everybody okay where we are so far? Now, in the past, when we've had multiple things in the numerator and one thing in the denominator, a very common strategy is to break that up into multiple fractions. We did that with derivatives. We did it when we first learned antiderivatives. So let's break this up into two separate fractions. So that's secant of theta over tangent of theta plus secant theta tangent theta over tangent theta.
That tangent squared theta for the second one?
Yes, it is. Okay, can you simplify that now? What does the first term simplify to? Samuel?
Cosecant theta.
Cosecant theta. And what's the second term simplify to? Secant theta, tangent theta. Now, do you know the antiderivative of cosecant? We did learn it. You probably haven't memorized it. It looks very similar to the antiderivative of secant, except everything's co, and there's a negative. What is it?
Never mind. I don't think I have it.
The antiderivative of cosecant. Now, I'm not saying you should have this memorized, okay? If you ever needed it, I'd probably just tell you. Secant might be a different story. But the antiderivative of cosecant is negative natural log of cosecant theta plus cotangent theta. What's the antiderivative of secant? Tangent. It's easy, isn't it? It's secant theta. Are we done? Nope, dang it. Now I got to draw the triangle. So here's theta, right? Where's our defining equation? It's way back here. X equals tangent theta, right? So x over 1, square root of 1 plus x squared. So this is negative natural log. What's the cosecant of theta? Sine is opposite over hypotenuse, so secant would be ho. Hypotenuse over opposite. So that's square root of 1 plus x squared over x. Cotangent is going to be 1 over x. And secant is going to be 1 over the cosine. Plus chips. So that involves some algebra trickery, right? Question. Yeah.
Did we go over problem 143?
Oh, we'll learn more about this. Everybody go to this? Okay, 143, you sorry?
Yeah.
Can you tell me what it is? And then.
It's theta cubed d theta.
That's it?
No.
Oh.
I'm just waiting for you.
Wait, theta cubed d theta. Seems like that's out of order.
I mean, unless I just wrote it down wrong, but theta cubed d theta over the square root of 9 minus theta squared. D.
Oh, okay. Gotcha. Seriously, theta cubed over square root of what? 9 minus theta squared?
Yeah.
They use theta, so now we have to. Now we're going to have to say theta equals sine of x. You know what I mean? Like, that's annoying. But we'll just do it. Okay, fine. So theta equals what? This is a trig sub. 3 sine of x. So what's d theta? 3 cosine of x dx. So theta cubed is going to be 27 sine cubed x dx over the square root of 9 minus 9 sine squared. Right? And I actually forgot d theta. I don't know if you guys realize that. When you were writing it down, did you guys forget it, or did you just copy what I wrote? And you know why that happened? You know why I did that? Because it's reversed. Like theta and x are reversed. And so because I had already written sine squared x, like, I don't know, I think that just screwed my mind up. Yeah.
In the online book, it actually has two d thetas in there. So one d theta on the top and then also one to the right.
What?
So like it's theta cubed d theta over the bottom, and then there's also d theta.
That's a
on the right.
typo.
Yeah, that's what I thought because
Yeah.
I couldn't complete it, and I was like,
That's 100% typo. Because that doesn't make any sense.
yeah.
Even if it was a double integral, it wouldn't make any sense because you'd have to have some other variable. Talk to me.
I was gonna ask it, would you ever have a case where you have multiple d thetas or whatever?
You'd have multiple d somethings, but they wouldn't both be thetas. It would be d theta and dy, or d theta and d rho and d phi. I mean, that's what we're doing in Calc 3 right now. But so can we simplify this? Clean that up. So what is it? What's the denominator simplify to? 3 cosine? So this ends up canceling with that, right? So we're left with 27 sine cubed x dx. Yes? How do you integrate sine cubed? Change it to sine squared times sine. And now how do I integrate that? U sub. So u equals cosine of x. Du is sine of x negative dx. So this is negative 27 times 1 minus u squared du. So that's negative 27 u minus u cubed over 3. So that's negative 27. Now I'll go back and resubstitute. Cosine of x minus cosine cubed x over 3. And now I'll go back and put it in terms of theta. Good Lord. Okay, so you got to be careful here. When I draw the triangle, what's the angle? What's the angle when I draw the triangle? What? X. So x has a sine of theta over 3. I mean, that's backwards, how we normally would do it. Looks stupid. So now 27 cosine of x is radical 9 minus theta squared over 3. And then cosine cubed will be that same thing. So like this. How's that? Now, do you want to simplify that? I mean, I don't. Yeah.
Isn't it just simplify down to like 1/81 9 minus Theta squared 3/2. Power 3/2.
I don't know. I mean, I didn't do it, so I don't. I mean, I have no idea.
What?
Where did you say 81 or something over 80?
I did 1/80.
Oh, 1 over 81. Okay, I was gonna say, I don't see how 81 would be in the numerator. Okay, yeah, that makes sense.
I did mine as like a 1/3 times 1/3 type thing, not 3. I think you're right.
Yeah. But I mean, really, if you simplify that, like it's an algebra flex. That's what that is. I mean, okay, fine, you can do some really fun algebra. That's useless. But all right, other questions? Maybe just for fun, yeah.
So I have a question about some degree, not just the question itself, but like in the book, it gave an answer in terms of x, even though it was a definite integral. That doesn't make sense to me.
What number?
Number 153.
It was a definite integral and it gave you an answer in terms of x?
Yeah.
Probably a typo. Because it shouldn't, right? I mean,
Yeah.
if it's a definite integral, the answer should be a number, right?
Yeah. I got a number and then I checked the answer and it was like wasn't a number.
What is it?
The integral from -1 to 1.
Of 1 minus x squared to the 3/2 power? Yeah, that's the one. That's the one, friends.
That's the one we're talking about.
This is the one that ends up getting cosine to the 4. Did any of you do this problem? Did you get cosine to the 4th in the problem? Yeah. If you got to the point where you have integrating cosine to the 4th, you were doing it right. But then how the heck do you integrate cosine to the 4th?
Use substitution, or not use substitution, integration by parts. Cosine cubed.
Maybe you can do. I tried it by parts with cosine squared and cosine squared. That didn't work. Cosine cubed and cosine worked?
I think so.
I might try that after we're done with this one. All right. So let's go ahead and do the substitution real fast. I hope everybody sees that it's x equals sine theta, right? That's pretty easy. So now we're at 1 minus sine squared theta to the 3/2 power. And then, whoopsies. Then dx is cosine theta d theta. Right? 1 minus sine squared, cosine squared. So now I have cosine squared theta to the 3/2 times cosine. And when you do this, you get cosine cubed times cosine, or cosine to the 4th. And there it is. That's the one that stumped me. It's kind of embarrassing now because it's so obvious in my head. All right, about 3/4 of the way through this last period, because I tried a bunch of different things, and then about 3/4 of the way through, I saw it. And it was because of Colin, something Colin said that like jarred my memory, and I was like, oh, but we didn't have time to finish it out. But we'll do it now. Okay? So what's the problem with cosine to the 4th as it stands right now? You don't know the antiderivative. Right. Okay? That's a problem. And you might think, oh, can I think of this as cosine squared squared? Is that true? Are those the same? Yeah, period, someone wanted to say, well, I know the antiderivative of cosine squared. Can't I just square that? It doesn't work that way. Right? Boy, this would be so much easier if that weren't cosine squared. In fact, this would be so much easier if that weren't a power at all. Now, I could change that cosine squared to 1 minus sine squared, but that doesn't really do much for me. It doesn't do much for me because I need, in order to do powers of trigs, like you need to put everything in terms of cosine and then have an extra sign hanging on the end, or vice versa. But I don't have a sine and a cosine hooking up here. Right? And I can't get one. I can't create a sine in this without getting rid of the cosine. Because it's even. You seeing that? Because I'll end up having a cosine squared. But if you go back to the double angle identity, the cosine of 2 theta is equal to 2 cosine squared theta minus 1. It's also equal to cosine squared minus sine squared. And it's also equal to 1 minus 2 sine squared. It's equal to 3 different things. Okay? But because this is true right here, this is true. And this is true. Now you might think, what do you do? How's that helpful? But it is. Because watch. Now this cosine squared, I'm going to say is equal to 1 plus cosine of 2 theta over 2 squared. Yeah? And if I square this 2 here in the denominator, that's going to be a 4. And this will make it cleaner for us. Oh, I forgot d theta. Forgive me. Now, what do we do here? What happens if you expand that, if you FOIL that, if you square that? You've lost the 4th power, right? So if I square this, what's my first term? 1 plus 2 cosine 2 theta plus cosine squared of 2 theta. Yes? Okay. Can I do each one of these? What's the antiderivative of 1? It's theta plus. What's the antiderivative of 2 cosine of 2 theta? Now you can do it in your head, or if you have to do the little u substitution, do it. Isn't it just sine of 2 theta? What's the antiderivative of cosine squared of 2 theta? Oh, shoot. I know the antiderivative of cosine squared of 1 theta. What's the antiderivative of cosine squared of 2 theta? What do you think?
1/4.
Oh, you're giving it to me simplified. You know what I'm going to ask you is how you got that. Okay, so you're going to say 1/2 times what?
2 theta,
Plus
plus 1/2 or sine 2 theta, cosine 2 theta.
So why is this 1/2 here? Because there was really a U sub that happened. Okay, and I think just so everybody sees this, I'm going to work it out. Okay, so right here I'm going to say U equals 2 theta. Du is 2 d theta, right? So du over 2 is d theta. So this is the integral of cosine squared of u. Du over 2. So now I've got, oh, well, I know the antiderivative of cosine squared. It's 1/2 times u plus sine u cosine u. And now go back and resubstitute. That's 1/4 times 2 theta plus sine 2 theta cosine 2 theta. Okay? So final answer here is this. Well, not final answer, but almost semi-final answer. 1/4 theta plus sine of 2 theta plus 1/4 times 2 theta plus sine 2 theta cosine of 2 theta. Oh, forgot parentheses. Are we done with this problem? No. Because what do I have to do? What do I got to do? I either have to put it back in terms of x, or leave it in terms of theta and change the bounds. Like when we do a U sub, we change the bounds. We can do the same thing here. We could leave it in terms of theta and change the bounds. But let's put it back in terms of x. Because everything's going to come full circle here. Do you want to simplify this first before we put it back in terms of x, or do you just want to go? Because I can do some cleanup here. I see a 1/4 theta here, and I see a 1/4 theta there. And after I distribute that, you guys see that? So let's go ahead and do that. So I'm going to say what's 1/4 theta plus 1/4 theta? 2/4 theta. So that'll be theta over 2 plus sine 2 theta plus 1/4 sine of 2 theta cosine of 2 theta.
Why is it theta over 2? You're adding 1/4 theta plus 1/2 theta. So shouldn't it be 3/4?
Oh, you're right. I'm terrible at adding fractions apparently. Yeah, 2/4 is the same as 1/2. So 1/2 plus 1/4 would be 3/4. Good job. So you want to put it back in terms of x? What do we have to do to put it back in terms of x? Draw the triangle. Oh, okay. So x equals sine theta. So here's theta. x over 1, square root of, whoops, I did that backwards, x over 1, square root of 1 minus x squared. Okay. Uh-oh. What's the problem? What's the problem? What is it, Gavin?
It's 2 theta, not 1 theta.
I don't see 2 theta in the triangle. Can I just double all those things? Does it work like that? But sine of 2 theta is 2 sine of 1 theta cosine of 1 theta. Sine of 2 theta is sine of 2 sine of 1 theta cosine of 1 theta. And cosine of 2 theta is, well, pick whichever one you want. How about we use the one that's written there? 2 cosine squared of 1 theta minus 1. Now I'll put it back in terms of x. What a hot mess this is. Yuck. So I put this back in terms of x. That's going to be 3 theta over 4. So 3 inverse sine of x over 4 plus 2 sine theta. Sine theta is equal to x. Cosine theta is equal to radical 1 minus x squared plus 2/4, 1/2. Sine theta is equal to x. Cosine theta is equal to square root of 1 minus x squared times 2 radical 1 minus x squared minus 1. Oh. I'm sure that simplifies. Now we have to evaluate that from -1 to 1. But thank God. Do you see what's going to happen when you plug in 1 and -1 inside that radical? All those pieces that have 1 and -1 in the radical are going to be 0. Right? If you plug in 1 in that radical, you get 0. If you plug in -1 in that radical, you get 0. So anything with a radical in it is going to have 0. So the only term that really matters there is 3/4 inverse sine of x over 4. Or 3 inverse sine of x over 4. So what does this end up being? Like 3 inverse sine of 1 over 4 minus 3 inverse sine of -1 over 4. So this is 3 pi over 2 divided by 4 minus 3 times -pi over 2 over 4. So that's 3 pi over 8 plus 3 pi over 8, or 6 pi over 8, or 3 pi over 4. Holy moly! That was a mess. A hot mess. All that for cosine to the 4th. Isn't that interesting how it's like, If you just go back and look at the original problem. Look how simple the original problem just looked. I mean, doesn't that just look like, that didn't look that hard. 1 minus x squared? Okay, no big deal. Yeah.
Are we ever gonna see this problem again?
I don't know. I mean, would I give that problem to you on a test? I mean, it'd have to be a short test. I mean, there's a lot there, right? Yeah.
Tomorrow is ACT.
Yeah, you look kind of lost.
Yeah, so if you're not gonna be here tomorrow because you're doing the ACT thing, I mean, you're gonna still, you'll have to take the quiz on Monday, and then you'll have the video to watch. You have a quiz on trig subs tomorrow. You will not have this problem on your quiz, for sure. It'll be much simpler. Much simpler. That's awful.
Can't we go back to solving like 3x plus 4 equals 2 stuff? Why can't we go back to those right now?
Yeah, I don't know.
You can wait till lunch or anything.
Till lunch.
Like
Tomorrow?
No, I mean, you can just order part two. No, you don't. You don't need to.
Hey, that's not what I.
So I distributed this. Oh, you're right. I didn't put it on this term and that term. I just did it for these. You're right.
Yeah.
Yeah, I'll need to fix that on Monday. Bring that up.
Okay.
Yeah.
Ew. Oh, what's wrong?
Yeah, and that's why, because I didn't distribute that for.
You're excited about the nachos?
So at first I was really confused. I'm like, I got